Okay, we're going to have a look at the complex number here, and in particular, looking at some operations we can do with the complex number. So let me first explain. I've got two complex numbers here, and the complex number for z is made up, let me just rewrite this, of a real number, which is the first part, 3, and an imaginary part, which is the second part, and that's indicated by the I. And remember, the I is the square root of -1. So this is an imaginary number. So here we've got an imaginary number. Here's a real number. Together they make a complex number. And in general, we might see z given as a plus bi. So we've got real, imaginary, making up a complex number. And you often see complex numbers as a C. So you see it is included as a C, big letter C, as opposed to the real numbers, which are R, or the fractions and quotient numbers, which are Q. So that C is complex number, and that's basically complex numbers. So let's have a look at some operations we can do with complex numbers. So I've got my two complex numbers here. And what I'd like to do is to, once I've moved this up the top of the page, is just simply add up the complex numbers and then take them away, multiply, and divide. So there's simple operations we can do with them. Adding, let's add z and w together. And this is a real straightforward thing. All we need to do is add the real part with the real part. And then we add the imaginary part with the imaginary part. So this is plus 2i and this is minus 4i. And I is just like a letter you use in algebra here. So it becomes minus 2i. And we're going to do a similar thing. Let's do w take away z. So for this one, I'm going to do 1 take away 3. So that's the real part. And I'm going to do minus 4 take away minus 2 to give me minus 6i. Should be no problems with adding and taking away. Now I'm going to multiply these two together. So what happens when I multiply these two together is slightly different. So we're going to have 3 plus 2i. We're going to treat this like a quadratic equation, if you like, when we expand two brackets and we turn it into a quadratic. But some things happen here because of the i's. So obviously we've got the real part times the real part here to give us 3. Then we've got 3 times negative 4i. And just like you're doing an algebra sum, we're just going to think about that I being a letter, like x. And so it's just negative 12i. And then I've got 2i times 1. Well, that's just 2i. And you can see that I'm going to put these two together in a minute. Now, the interesting thing happens when I multiply these two things together. Because 2 times negative 4 is going to give me negative 8. And I've got I times I, which is I squared. So everything here is fine. That's okay. But look at this I squared. Now I is the square root of negative 1. So I squared would be just like taking away this square root sign, so it becomes negative 1. So I squared is negative 1. So this becomes positive 8 without any imaginary part to it. So that positive 8 without the imaginary part becomes 11, because I'm going to have 3, add 8, and then these two can be put together and simplified to give me minus 10i. So that's how you are going to multiply out your complex numbers. Just remember that when you multiply these two imaginary parts together, it's actually going to give you a real number. So let's do the one with division now. So let's do this again. And let's add my two complex numbers here. And I'm going to do, doesn't really make any difference which way I do it. Let's do z divided by w. And when I divide these complex numbers, what I'm going to do is a little bit like when you or may have done surds. You're going to do 3 plus 2i divided by 1 minus 4i. Now what I'm going to do here is I'm actually going to multiply this by 1 plus 4i and 1 plus 4i on the bottom. Now that number there is actually 1. That divided by that gives me 1. And you can probably understand where I got this from, because I've got a negative here and a positive here. It's very similar to doing surd division, or rationalizing a surd. Now let's do the top. 3 times 1 is 3. And here I've got 2 times 4i. So I'm doing this one as well, because I know this is going to give me a real number from the multiplication from before. So that's 3. And this is going to give me positive 8i squared, which becomes negative 8. So this is going to give me negative 5 on the top. 3 times 4i is 12i. And 2i is going to give me 14i. And then on the bottom of this fraction is going to give me 1 times 1 is 1. Negative 4 times negative 4 is negative 16. Negative 16i squared becomes plus 16. So 1 and 16 are going to give me 17. Now, I'm not going to bother with the rest, because if you look at this, well, I will just quickly, but you don't need to. That's going to give me 4i, and that's going to give me negative 4i, so they cancel out, thus rationalizing the bottom. So quick recap, we've learned that complex numbers are made up of real parts and imaginary parts. We can add complex numbers together. We can take away complex numbers. We can multiply complex numbers, and we can divide complex numbers.